Alright, so I'm just going to run you through some examples on trig ratios. If you haven't watched the video on the ratios yet, I highly recommend watching that before we get into this one. I'm just going to steal the examples from the textbook. The textbook I'm using is Michael Grove, Math in Focus. Pretty good textbook for an introduction to this sort of stuff. In terms of the harder stuff, I might avoid it. Question 1, I'm going to start by simplifying, and we're doing tan 50 minus cot 40. Okay, so in the last videos on our trig ratios, we talked about complementary ratios, and we said cot is cotangent and tan is tangent, so these two, they do go together. Okay, so the property states that then if you have tan theta, that's equal to cot and 90 minus theta, the complementary angles in there. So if I have cot 40 here, well, cot 40, well, tan 50, let's go to tan 50. So tan 50 equals cot, and it's going to be 90 minus 50. Of course, just substituting in 50 for theta there. So tan 50 is actually equal to cot 40. So this question then is the same as cot 40 minus cot 40, which is, of course, 0. Taking a second question. So our second question, we've got find the value of m if sec 55 equals cosec 2m minus 15. Okay, sec, cosec, secant, cosecant, again complementary angles. Okay, so our theorem here is saying that sec theta equals cosec 90 minus theta. Okay, so if I do have sec 55 is equal to cosec, and it's 90 minus 55. So sec 55 is equal to 90 minus 55 is going to be 35, I think. It's holidays. So it's going to be cosec 35. Okay, so back up to our question then. Sec 55 is cosec 35. So we've got cosec 35 equals cosec 2m minus 15. Okay, so just equating these two here, 35 there, 2m minus 15 in there. And just solving that like an equation. Add 15 to both sides. We get 50 equals 2m. So m is 25. Okay, they're the two standard examples from the book. I'm just going to find something a bit more substance for you. So a question might say, if let's say, I'm going to have a quick look, pick at the textbook. If tan theta equals 4 and 5, find cot theta. Let's go sec theta, and we'll say sine theta as well. Okay, and we're going to assume here that theta is between 0 and 90. Okay, when you get to do trig a little bit later on, you'll find this is not always the case. So specifying here is going to seriously limit our results, which is a good thing at this stage. Anyway, taking what we've got tan theta is 4 and 5. So what we're going to do, we're going to construct a triangle. Theta there, and make it so tan theta is 4 on 5. Tan theta we know is opposite over adjacent. So for our theta here, opposite's 4, adjacent is 5. To find the hypotenuse here, just doing a little bit of Pythagoras. So my value of c there, c squared equals 4 squared plus 5 squared. So it's 16 and 25, which is 41. So c is root 41. In terms of finding values, firstly, part I, change color here, part I, cot theta. Well, we know cot theta is 1 on tan theta, or tan theta flipped upside down. So here, it's going to be just 5 on 4. Part 2, sec theta is 1 on cos theta. Okay, again, going on with that third letter there, c is cos, 1 on cos theta. Cos theta here, cos adjacent over hypotenuse is 5 on 41, so it's 1 on 5 on root 41, which flips it upside down, gets you root 41 on 5. And last but not least, sine theta. Sine theta here is 4 on root 41. Okay, of course, you probably want to try and express that with a rational denominator. We are past the stage of leaving it irrational. So multiplying top and bottom by root 41. It's going to get us then 4 root 41 on 41, and that can't be simplified. Have a go at a bunch of these, get into them, especially if you're doing extension 1. The skills, knowing how to play around with cot, sec, sine, the reciprocal ratios, the complementary ratios is going to be really important in terms of getting some of the proofs down later in this chapter. So make sure you're very confident with all the ideas presented to date. Thanks for watching and best of luck.